So, hello everyone. My name is Mateusz Kubuszok, as you heard, and I will be talking a little bit about Scala 2 versus Scala 3 macros. So, a little bit about me, so that because it's an obligatory part of every of those kind of presentations. So, I've been using Scala for more than 8 years, commercially working in general more than 10, working in general with programming, even non-paid, but just as a hobby for 18 or so. And one of those things I was doing in the meantime, it was co-authoring one macro-heavy library called Chimney. You probably haven't heard about it. It's very niche library, but it taught me quite a lot about macros. So I will use this experience to show you a few things about the differences between Scala 2 and Scala 3. And I also did a little bit of blogging or writing some ebooks. So let's get to the main topics. The agenda for today's presentation is as following. First, we will start a little bit with reminding ourselves what are actually macros, at least how we can understand that intuitively, because the formal definition isn't very useful for your everyday work. Then maybe we'll mention a little bit about what are expressions and types, at least in the context of macros. What are the symbols? Because this part is not something you generally see when you are working in your normal everyday code. And then we will also see some examples showing how those different concepts works. We can see some comparison between how things are implemented in Scala 2, how in Scala 3. Are there some differences in API, some conceptual? Are things always the same or not? And I also will try to focus only on those things that I have personal experience with. So, we cannot cover all the differences between Scala 2 and Scala 3, but we will just showcase enough examples to give you some sort of intuition what you should expect when you work in either of these versions. And I will also not talk about macro annotations. As far as I remember, on Scala 3, they are available since about a year as experimental, but they won't be used on stable Scala for quite a while. So let's focus just on the macro definitions. So first thing is, what is a macro method? My personal intuitive understanding what it is, which I find really useful when I work with the code, when I drawing my expectations, what will work, what would not, is that this is basically a code generator, which is pretending to a method of some object, but which actually is not a method of this object. And we will see some examples why the distinction matters. So let's take a look about some example of a very simple macro. I have it prepared right here. That I will explain later. This is quite important. Oops, I have the focus. Yeah, so this is like a very, very simple macro. As you can see, it compiles quite a lot because for various reasons I had to disable the BSP server compilation, so all those examples will compile quite a lot. Unfortunately, the bug is reported, so Okay, but when it goes to this macro, as you can see, it's very, very simple. The only thing it does is printing a constant string, because I wanted to avoid all the noise when you want to understand, the simplest thing. So here we see how we are defining the macro method. We're basically trying to make it look as a normal method, but its body have to contain only one thing, and one thing only, which is the keyword macro, followed by calling some method implementing this macro. And basically, it will tell the compiler that, okay, when you will be asked to call this method, try to run in the compile time this very method and get the whatever is generated by this method and put it in the place where the call set is. And we can see, in the example, that when we call this method, we are getting some result that we can printing this result. So we can see that, yeah, it's some constant string as expected. Assertion also like works. We also see some things that are kind of required when we are working with macros. One of them is that we have to basically enable macros so that Scala 2 would not complain, because Scala 3 is already released. Scala 2 is basically at the end of its life. It will be just some sort of life support for a while, but nowhere during that time macros went out of this experimental phase. So if you are using macros in Scala 2, you always have to basically import this experimental flag into your scope or set a flag in your build. You also have to import this library. The exact version of this library depends obviously on your exact version of the compiler, so you always have to import it so that you are able to access those macro APIs. And then, as you can see, if you need to use macros, you always have to use those path-dependent types when you are importing something called context, which contains all the APIs that you would be using, and also the output types like expression, on type, or whatever, are also defined in terms of path-dependent types of this thing. So how it looks on Scala 3. So as you can see on Scala 3, this simple example have some similarities. You have to have this method which will be calling macro. You have to have this method which will be containing the macro. They always have to be separated. But the keywords are kind of different. Here you can see that instead of having this macro inside the method, you have to have the inline outside the method. But the fact that you are having some implementation method which will return you expression, which will be taking some parameters, giving you the API to access the internals, that does not change. However, as you can see, you have this code which is looking quite similar to normal Scala code, as opposed to, well, basically working with strings. If you take a look at how I constructed this string, I have to do this thing called quasi-quote, which means I am trying to write something which looks like a Scala code. It not always is. And then put it all inside the strings, and then compiler will interpolate the string into something internal, something which Scala compiler understands. So obviously, no way that code completion will work. While with this, at least you have the syntax highlighting or so. So when we see this example of a simple macro, we can already see a few patterns. One is that we have those impl method, the method which is called. We have this expression, which is the AST of the code that we are trying to create. The important thing about expression is that it always describes some value that you could get in your program. So you cannot just have a part of the program and call expressions. No, expressions are always like a complete values, and they have a type. You don't always know this type, but at least you know it has it. In Scala 2, you could see that I used the black box keyword. If we have a time, then I will explain why it's called black box. If not, then, well, you can find it online. And also, you could, maybe you have noticed, but while here the expression is a path-dependent type, depending on the context, on Scala 3, this is kind of global. So expressions and types are not depending on the context. It makes coding sometimes quite a lot easier, because you don't have to trying to figure out how to shred those path-dependent types. If you try to create some utilities and stuff, so it's kind of handy. You can also ask the question, okay, do I always have to put all those two methods in the same place? And happily, the answer is no, because that would be quite pointless if you define those two, if you always have to define those two methods, like macro method and the macro implementation in the same place. That would kind of pollute your API, so it wouldn't look quite good. So we can see some example how we can separate those things. So one thing you can do is have macro definition in one place, macro implementation in another place. Here I have those two things in one in a component object, one in the class, but in reality you do not even have to store those two methods in the same package. You can create a internal package, put all your macros there, hide it from the user side so that it will not pollute the API, so the user will always see what they are supposed to see. So that is quite handy. The same is true for Scala free. You don't have to store everything in one place. Okay. So yeah. So they don't have to be in one same package. The only requirement that we have is that when you have this macro implementation that you will be linking to with either implicit, inline def or with a macro, they have to be in a different compilation unit when you're trying to call this macro. Which is why all those examples that I showed you are split into the two parts. When I have macro and the other when I have a test, because I wouldn't be able to put all of that in a single compilation unit, because Scala would just complain, tell me that sorry, those two things have to be in different compilation units. So yeah, that's that's kind of the suggestion that macros don't work the same way as normal methods. But what we do that but let's try something more complicated. Let's instead of returning a constant value. One example you have right here. So I'm defined some method, like a normal method, not a macro method. But inside the macro, I'm just calling this method to generate the code which would call this method. And as you can see, it works. The method is called. So far we might even believe that macros and normal methods are very, very similar. In Scala it should look the same. The only difference is, as you can see, that I am using the full qualified name, because while Scala free is a very context aware, and it sees that if I call a normal method, I will mean exactly this thing in the same scope. Scala 2 is kind of less clever, so if you will not use those fully qualified names, then you might be surprised what will be generated. So you have to be a little bit more careful than usually. But this method calling is not the same as with a normal code, because what would happen if I made this method private? When you would learn that we cannot compile that. Why we cannot compile that? Because macro is a code generator instead of a normal method. So imagine if you wrote this code by hand. So imagine that here when we are calling this macro method, you would write the code that takes this Scala example and try to call this private method. You wouldn't be allowed to. And the fact that you're using macro doesn't change that. So it is just a code generator. It is not a method which has access to all the private methods, private properties, package private or whatever. You can only access things that would be available to a normal code. With some exceptions, but we'll get to that. Same is true on Scala free. If we try to call the private method, inside the macro, it looks as if it should work, but compile will tell us that, sorry, you cannot do this. Okay, so let's do something even more complicated. Let's try using some parameters in our macro. As you can see, things are getting a little bit more complicated. Yeah, code works. So as you can see, in Scala 2, when we want to introduce parameters into the macro, whether they are type parameters or value parameters, the name has to be exactly the same between those two implementations. So I wouldn't be able to just call this A expression like B or AX or whatever. Scala will basically complain if I use any other name. So I have to basically have the same order of parameters, the same names of the parameters, otherwise I will get complaints. The only difference is that this context will have to be in front of all the rest of the parameters. When it comes to Scala 3, things are a little bit more leeway because those parameters aren't automatically passed for you, so there is no convention. When I get this parameter A here, I have to pass it manually into the macro. And because I am passing this manually, there are no conventions forcing me to use any sort of like naming conventions or parameters order, or for preventing me from passing some other things into the macro. So that's one of those differences, which are just pretty superficial but noticeable. The other thing we are doing here to like show the usefulness of the macro is that we are basically trying to print this value that we pass to this macro. This is just basically an example of printing the code what we pushed into the macro, creating some string out of it, and the string will be accessible in the runtime. And you can see that there is like several methods which you can use to print things. There is show and show code, which are almost identical. You hardly ever see the difference. They basically trying to show you the expression as if some programmer wrote it. You can see show row, which is like a print of this AST. You can actually like see this print right here. Like if I pass this code here, it creates a tuple, but it's a whole expression creating a tuple, not just the final result. And you can see that Scala would just use this extension method, which takes one, calls only this method arrow, puts the string inside. This is the show code. As you can see, usually they're pretty similar. This is the show row, and this is where things are like very interesting, at least if we want to maintain macros, because as you can see, well, that's how the AST looks like. And sometimes you would have to just, be able to access those kind of data because, well, let's say it straight, documentation is pretty lacking. If you want to figure out how to build certain expressions, you have some utilities. Documentation of Scala 2 mentions how the quasi-quote works. Documentation of Scala 3 mentions how quotas works, but everything else is like, if you remember this meme about this drawing of an owl, start with drawing two circles and draw the less of the owl. So that's how it goes when it comes to the documentation of Scala macros. You basically have to learn things by reverse engineering what you are supposed to construct at the time. Which is why those printing expressions are so important, because without them you will be just completely left in the dark. And those other prints show how we can print the type. So you can see that there is this target type. That's the Scala 2 way of passing the information about the type parameter or parameter in general as something which is typed. This would be like a C-weak type tag of A, and you would be able to access the information what this type is. But you also have this thing like weak type of, and as we will see better in a moment, basically there are like for both expressions and types in both on Scala 2 and Scala 3, you have two different representations of certain concepts. One of them is type. You have this type parameter showing that what kind of thing is inside, and the other is untyped because it's like pretty raw value used by compiler, which we can manipulate, but without making sure what kind of what kind of stuff you have inside. So you could see that like for expression, this in Scala 2, this field is called tree, and for types you have type tags and types. On Scala 3, those names are a little bit different. When you turn the expression into this untyped thing, we call it term. And when we turn type into this untyped thing, we call it type wrapper. And instead of having separate methods, you are actually using this printer to customize how you want to print things. So for instance, if you define no printer, when I just want to print this result, basically you can see that Scala does a little bit of shenanigans, which is like Scala 3 tries to kind of pretend that this macro is a method, but not completely. And this pretending works in a way that when you're passing this value inside, instead of passing the whole expression, it takes this expression, puts it inside some value to stabilize the result, and so you can see that what you get when you get this expression, instead of having this whole expression which computes this value, like here, instead we are just getting this value containing the result of this expression, so that every single time you would call it, it would be computed only once, and you can see that you have quite a handy thing, which is like which is called tree ANSI code, which basically makes sure that when you're printing this code, it's pretty printed, so it's a little bit easier on your eyes. You can see that when it comes to normal code, it's colored. When it comes to types, you can see that it's also like coloring, not the name of the type is using magenta, but those parent square brackets not, so it's a little bit easier to read. And of course, you can also like print the structure version of this code to read how it actually works underneath, which is not something you want to look at, but sometimes you have to. So if anyone is interested, I prepared some tables. It might be a little bit too small to read right now, but both the presentation and examples are on my GitHub. So after the presentation, if you ever wanted to access this kind of information, you can see those comparisons between those two things one-to-one. So far, we could see that Scala 2 requires us to pass this black book context. Scala 3 requires us to pass this quotes. Like Scala 2 has weak type tag. Scala 3 has type. Untyped version is called type in Scala 2, type rep in Scala 3. Expressions, well, they have the same name in data, just defined in different places. There is also this one thing called prefix, which I could also show you, which only exists on Scala 2, not on Scala 3. And it also tells us a little bit about how macros works. So when we have this object and we would like to print it, like print this. Like on Scala 3, you see that if I wanted to print this, I have to pass it manually into the macro, because I always have to pass manually everything into the macro. And as you can see, when I pass this, it's available to the internals of the macro. I'm able to build some expression with it, or I am able to print it, or whatnot. But you can see this manual work that I have to take this, pass it inside. Obviously, I will not be able to call on the private method on this disk, because it's just a name. It's not an actual method which can access some internals. But on Scala 2, I do not have to pass this parameter. I do not have to pass this part before calling the method so that it would be accessible inside of macro. And it's called C prefix, which is like very intuitive, but it also shows you how macro developers thought about these things. They didn't consider it as like, proper method. It's just, code again. So when you want to access this, it's not like this, it's a prefix, something which appeared before the call to a macro. And it exists only on Scala 2 because on Scala 3, the way things are called is kind of different. Like other things that what might be useful to you is like how to convert to and from type representation to untype representation. So I have some examples here. If you wanted to see it, then I'm recommending to use to just read those slides after the presentation, so that we will not dwell too much of the matter. When it comes to comparison, how different ways of printing macros works, I also prepared some list for you, so if anyone is interested, they can access it. And there is also when we are out printing, we might also like wonder, okay, printing with print line on whatever is nice, or like returning the string, but how could I return some information from the macro? So there are methods for this. As you can see, they are all defined in this context. We have like 3 levels of logging. We have info, which is here called echo. We have warning. Abort, what is like on an error reporting, and also like termination from macro, so that we will get compilation error. And as you can see, we got those nice error messages showing us where the error happened. When we have error, it shows that we have one error. When it's just like info or something, when we have just printing this information and showing us, okay, which part of the code generated this information. And this is actually the reason I have to turn off this BSP server, because there is this bug inside the Scala CLI which only prints errors, and if you try to report info or warning from the macro, well, it's not supported yet. So you can also see that there's something like in a closing position. This is basically a way of telling those reporting methods where this nice error should be, so that user would see, okay, this is the place we generated this message. Things work similarly on Scala 3. We have with something like position. Things are placed in a different object. Different object is not in like context, but on this module called report, which we have to import from quotes. But as you can see, it works pretty similarly. Just one limitation of all of those methods is that basically only the first call of the method is actually used. So you cannot just use it like a print line. You can just say, print, and all of that land on your screen. Only the first call to each login level will be printed. So if you want to somehow like aggregate errors or aggregate messages, like analyze everything inside your macro and then have one summarizing error at the end, then basically you have to somehow combine those values before you call these logging methods, and only then call them once. Okay, so far we have only like simple things like printing what we got and just showing it, maybe reporting errors, but we haven't analyzed anything outside our macros, and those are the things where the differences started showing up between those two versions. When we were analyzing the type, we will see that something called symbol appears. So symbol is basically like a reference to anything which has a name, which has a name for the compiler, because anonymous classes also has name from the compiler point of view. So like types, classes, vals, vars, methods, parameters, bindings when you are using pattern matching, all of those things which have like a name you can refer to. You can consider that they probably have something like a symbol from the point of view of the compiler to be able to point, okay, this is what I mean. And And that's more or less how it looks like. When we have a type, we can extract this type symbol. Like here we have two types. One of them comes like from the class. One of them comes from calling the macro. We have some arguments passed there, and as you can see, we can take those two types in their untyped version. We can extract those symbols from it, and those symbols have a lot of useful methods, like getting the full name of this thing, checking whether it's a symbol of a type, class, module, and so on, and just show a few examples. If we know that this is a class, we can ask it, what is the primary constructor, so that we could start analyzing this primary constructor. What kind of declarations we have in this class? What kind of members? The difference between those two things, as far as Scala 2 is concerned, is that declarations are all the methods or values that we define directly inside the class, while members might be basically anything that we might also inherit it. So depending if we want to only look at the things we have inside the class or inherit it from somewhere else, we might look at different methods. And if we take a look at this example, when we have just foo, and we try to transform to bar. If we want to see how Scala 2 macros sees those things, we can see that we have a symbol of the class knows that this is a class. It knows the full name of this class. It knows that this is a type, that this is a class, that it is not a module symbol. This is not a term. That it has a constructor. That it has those methods defined directly, either by us or by the compiler. It has much more methods inherited, for instance, from Java's object. Same with this other type. It works pretty similarly on Scala 3. You also have a symbol you obtain from this untyped representation, which is typerep. Yeah, it also print things pretty nicely. Well, we can see some minor differences, like how the full name is defined, or how the primary constructor is called. You can also see that Scala 3 created this distinction, because instead of having decls, which is like declarations and members, here we have things split into fields and methods. So we can always only ask about vals or vars, or we can only ask about defs. And might be kind of handy. And this shows when we are printing. As you can see, declared fields only contain vals, and declared methods only contains, well, methods. So when we compare to those things, if we look really deep into that, and let's do just a short summary, because it would be too much to discuss all of that. If you look pretty closely at both the code, you could see that I calling things like as type or as class or as module to access some methods very specific for the particular kind of symbol, depending on what it describes. On Scala 3, we have only one kind of symbol, so things are pretty simple there. You can see this example when I try to access the primary constructor. On Scala 2, I have to take the symbol, turn it into a class symbol, and then I can access primary constructor. On Scala 3, I can get it directly. There's also this thing called no symbol, which have two different ways of being accessed, both on Scala 2 and Scala 3. It basically is like a null when it comes to symbol. Some methods are returning symbol. The symbol is never null, but sometimes when you see the symbol, it makes no sense. Like when you have some types defined in Java, they have no primary constructor, so you have to return something. So we are getting no symbol. And also, as you can see, those methods like decls or members are split on Scala 3. And we want to do some sort of analysis on methods, we can also see some other differences. So I mean, some other interesting things. Like here, this example, you can analyze it more closely at home. It basically shows that when we try to work with lambdas are not treated as methods. As you can see, when I got the symbol of a lambda, it's treated as a class, as a type, but it is not a method, it's not a term. So compilers see the differences between functions and methods. When it comes to methods themselves, here I am also like printing the type parameters or param lists or the return types. So basically, I'm doing this sort of analysis that when I get the type and I see all of this, its types methods, I can take a look like if this method has type parameters or if it has value parameters and what would be the type returned by this method. Then as you can see on Scala 2, you can access those things with methods called like type params, param list, return type, and those type parameters and value parameters are like distinct methods. Meanwhile, on Scala 3, you have only one method. It's called param_sims. And when you look at it, you have just nested lists which will tell you if this method has type parameters or value parameters or both or nothing. And if you want to figure out how to decode this, how to decode those definitions, then here we have a sort of like a summary how it works. Where the method has 0 parameters, you have like an empty list of type parameters and empty list of params in Scala 2. But when you have just a single empty argument list, then interestingly, you have this list containing only empty list, both on Scala 2 and Scala 3. When you start adding parameters to the method, they will start showing up in param lists and on param_sims. The fact that you have nested lists is quite important because when you are starting using multiple parameters lists in a method, then you will be able to see which parameter appeared in which list. But up to this point, you could always assume that, okay, on Scala 2, I always have like a single type parameter list at most, maybe some other lists of value parameters, and on Scala 3, Scala 3, those type parameter lists would always appear at the beginning, if ever. So, why bother? Why wouldn't we just, store it in those two methods as in Scala 2? So, on Scala 3, you have something like an extension method, and then you could see that if you analyze this type, you could see that first you have a list of first type parameters, then the list of value parameters, then second list of type parameters, and then second list of value parameters. So you could see that those type parameters and value parameters would be like interleaved. And even though right now it only appears for like extension methods, there is a proposal of something called class interleaving, which means that you would be able to basically define methods which would be able to like interleave type and value parameters, so you could just define type parameter, value parameter, type parameter, value parameter. It's just a proposal, but at some point it will probably most likely land on Scala 3, meaning that you will be able to define methods with types and params in such a way that Scala 2 wouldn't be able to understand, and why Scala 3 would, which had to be reflected in this API, which is why we why we have this. Okay, so let's build a simple expression. What I mean by a simple expression is just to demonstrate a few concepts. I want to basically take only a case class or a sealed trait, try to create a list with all the values of this, with a value of this type. If it's like a case class, it would be only I won't want to create this value if all the parameters of this case class have a default values. If it's a sealed, then if it's case object, I want to just create this value, and if it's a case class, then I'll only want to create it if all the values are default. So basically, I want to like try to best effort attempt at initialization this thing based on the type, just to demo how it will look like in the code, and maybe see if there are some differences between Scala 2 and Scala 3. So as you can see, even a simple thing require us to write a little bit of code. So let's analyze how it works. And as we can see, the code also like prints pretty nicely. So we know that it works. So let's see how it works. To check if something is sealed, I'm able to use the symbol API that I was mentioning earlier. If I know that this symbol is a class, then I can access some class method like is sealed. To check if something is a case object, there's a flag which checks it is a module. Well, basically all objects in Scala 2 are modules, and if it's a class, then I can ask if it's a case class. So case object is kind of like a case class, which is a module. If I have a module, then basically I can use this its symbol to create an expression. So basically, this is how I create an expression containing just case object. And in case of a case class, I am checking both it's a class, if it's a case class, and if it has a primary constructor, then if all the parameters in this case class have default parameters. So right now we might be wondering, okay, how do you access those default parameters on Scala when you're building the code? And the answer is you have no tools for that. Basically, if you want to use defaults in macro on Scala 2 and on Scala 3, you have to work how defaults actually work. And the way that default values works on Scala is that basically you're defining the method inside the object that has a method with default parameters. And the method's name will be something like method name. In case of we are talking right now would be like apply for a case class. Then you have $, default, $, and then at the end you would have the position of that type parameter within the method. So it would be like apply $default $1, apply $default $2, and so on. And so you have to basically, because we are talking about something used in a constructor, those default would be defined in a companion object, which means that if we want to construct this case class, then basically we start with getting the constructor, then getting all of these parameters of this constructor. We already, on this point, we already assuming that we check that we are allowed to access that all of the type parameters are using defaults. Then we have to manually compute the index of each of those parameters, like with zip with index, but because those are not 0 indexed but 1 indexed, we have to just increment by 1. Then we have to get the companion, get the types defined in this companion, and then basically get all of the methods, check if this method is named as we're expecting it to be. If it is, then okay, we got the stuff, we are able to call it, and we are able to call it, as you can see, and that's how we would access the default methods. And then when we have all of those methods, we are able to just call the constructor, and finally create our value. So once we defined all of these utilities, we can basically do what we wanted before, which is check if it's sealed, then get all of the possible subtypes of the sealed. This is quite often used method when it comes to Scala macros. If you are looking at all of those type class derivation libraries, because if you have a sealed thread, it will give you all of its subtypes, direct subtypes. Because if it's nested, then you have to repeat it again and again. But once you get all of those subtypes, then you can just decide if those are case object or case classes, instantiate them. In the meantime, you also have those nice little things like using 3 dots versus 2 dots Basically, the difference is if whatever you have to pass there is a list of something, or if it's just a list of something. Like, because constructor can have multiple parameters lists, you are just like we shown on the slide before, then it will be like a list of expressions. So you have 3 dots, and here we just want to use like varargs, variadic arguments. So I'm just using 2 dots. So those are those things that you just have to assume that you have to deal with this crap. So, and once you do, then when you call the macro, then that you can see that it actually works, and you are able to like create a list of my 2 examples. One of them is just simple case class, and the other one is sealed, which has 1 case class and 1 case object. And as you can see, we're able to instantiate that, and that we are manually calling inside the macros all those default methods. So this is the one difference that we have between generating code with macros and writing by hand. Like by hand, we wouldn't be able to call those default methods. Compiler would complain, but inside the macro we can. And as a matter of the fact, we kind of have to if we want to use it. On Scala 3, it works really, really similarly, which means that yes, you always have to check if things are sealed. The only difference is that how you check it, because those are not like methods inside the symbol. You have something called flags, and you are checking if those flags are checked. As you can see, the printing works great, and we also use those pretty printing. So yes, we were able to generate the working code. And kind of sad thing is that if you compare those 2 codes, like the one we have before in Scala 2 and one we have in Scala 3, on Scala 2, as you can see, we are using those quasi-quotes to expand those lists of type of arguments or to call those variadic values. And well, Scala 3 only let us use those quotes when we have expressions or types, like complete expressions, not some part of the expression, not so arbitrary thing which we would use to build expressions. We can only use those quoted expressions when we have like complete values, or we are using complete values, which basically mean that if you want to call this new, we have to construct it by hand, which is why I'm telling that you have to quickly get used to basically using all those printing of how this type structure works. Because if you wanted to figure out how to call a new by hand in Scala 3, first you have to basically write the code which calls new, print it, and then try to reverse engineer the process. On Scala, occasionally you also have to do this, but on Scala 3 you have to do this much more often. And also another small difference that you might notice is that the name of the default changed between Scala 2 and Scala 3. On Scala 2, we have what's called apply. Like if we define a default method in a case class, it was called apply because, well, we are defining apply method in a case class. But on Scala 3, someone concluded that, okay, we want to try to merge like the calling apply with calling new, so that it's unified, which means that those defaults are now defined for constructor, and constructor is called init, except that we are encoding this triangle brackets in it using some sort of encoding, which is why this method is actually called something like $less init $greater $default. And yeah, those are the kind of things that you have to deal with if you want to do some serious work with macros. And it's not written in a sort of tutorial, or as far as I can tell. You have to learn it the hard way. Also, like a trivia, because you are able to write code in Scala 2.13, and from the Scala 2.13 called some artifact compiled against Scala 3, if you use the flag while tasty reader. Same like you can have a code in Scala 3, which calls some code in Scala 2.12. And well, basically the bottom line is that your macro on Scala 3 might be able to deal with the code compiled to Scala 2.13, and the code in your macro on Scala 2.13 might be dealing with the code compiled against code in Scala 3, which basically means that if you want to be like super correct, then this code is wrong because you would have to check for both of these conversions. Otherwise, your code could break if you just cross compile different Scala versions. And once we get to this point, I think I can finally show the fun part, which is like the Scala in the closet, because so far people might assume that those macros are kind of sane, like maybe someone has some doubts right now that they are not, but in case someone does, yeah. Let's see some examples. One of those examples you could actually see right here. As you can see, this is an example of like my library where the macro failed, compilation failed. Basically, when you read the error from the assertion, basically, I was trying to use a default, but in an example before, I knew that some parameter has a default defined. I tried to access it in the companion object, except the companion object suddenly does not have this default value defined, which is like weird. And well, the answer why it doesn't is that let me just increase the code. Was I think here? Oh yeah. The reason is that for the sake of the demo, I just assume that I can trust the Scala compiler and just use the companion. And the truth is that you cannot, because due to some shenanigans, sometimes if you have nested objects, or if you define object and case class inside a method, or if you have all this kind of like a different stuff, well, what Scala compiler considers a companion object isn't necessarily what you consider a companion object. And if you wanted to actually handle this case properly, then you have to use this nice piece of code, which I don't think anyone understands at the moment. I also wouldn't say I understand it. Basically, it assumes that you have to kind of get something which is supposed to be companion, check that it is not a companion, then try to check if its parent is a companion, and if parents of a parent is a companion, and so on. And as far as I can tell, nobody, hardly anyone understands why it has to be done, how it works, or whatever. I personally borrowed it from JSON Scala, but if you look at the link I referred to JSON Scala, you would learn that JSON Scala borrowed it from Magnolia like 8 or 9 years ago, and you still have to do this. If I use this fixed code, the code would compile. And another funny thing is when you are working with Scala 2 is that in some other library I was working with, I think that. Yeah, I had this kind of code where, as you can see, I had this error while emitting value on whatever. It basically means that the macro compiled, macro was type checked, then Scala tried to generate the bytecode so that you would be able to use it, and then compiler crashed. And if you try to investigate what was wrong with the macro, then basically there is nothing wrong with the macro as far as you can tell. And then you are looking at what kind of code would fix this macro. And then you are learning that the code which would fix this macro is the code which basically remove all the type checking and then runs the type checking again. And if you try to, okay, maybe I have a bug, maybe I used wrong type checking, but maybe I did something wrong with the macro, and no, you didn't. When you try to print those three and try comparing them, the only difference you would find after like 8 hours of debugging would be that there are some internal flags that you have not set. The compiler generated them for you for reasons whatever, and they are different. And you have no reasonable way of fixing them other than getting the whole expressions and removing the types, adding the types again, giving this huge overhead on every single macro because you double the work. But yeah, this is one of those bugs. I tried to find if it was reported. I think I found something on Scala bugs, and I think it was 6 or 7 years old already. So I am not hoping that it's going to be fixed. So let's say that's for now when it comes to Scala 2. But there are also some enjoyable things about Scala 3. like, was it here? Scala free. Oh, sorry, I have to find it. Okay, Scala free. Okay, yeah. So like on Scala 2, you have some utilities which are allowing you to, for instance, figure out what would be the type or return type of of a value when you have a method. Normally, it's not that difficult until you start using type parameters, because then you have to figure out how those type parameters would be applied. And on Scala 2, you have this method which is called like type signature in. So you can take it method dot type signature in, give you the whole type in which this method was defined, and then you are getting the result. I think it would be like no. Yeah, this method. As you can see, those things are like one-liners. I want to get the list of the parameters. I want to get them all like in the right type. Just type signature in, and it's done. I want to get the return type. Just type signature in, and final result type, and I'm done. I want to get the type and type of all of its parameters by the name. Type signature in, and I am done. Then Scala free enters the stage, and well, if I want to get the return type, I have to basically type match this type and check if it's a lambda, because only lambda has the return type. So suddenly it's not a one-liner. And if I want to get the type of every single parameter that method has, to see how I could call this method, even if it's like use type parameters and whatnot, then suddenly it becomes quite an interesting exercise on pattern matching on different kind of things like method type, polytype, whatever. This is the code from like a month ago, because I added a new test case, and then I discovered that this assertion was triggered because I haven't noticed like a third way of doing this. And when I tried to ask this best Scala macros expert on Virtus Lab, he told me, no, sorry, there is no better way of doing this, which basically means that when you have Scala 2 and Scala 2 macros, the biggest obstacle you can have is that you have bugs not fixed since 10 years, and you have to deal with them. And on Scala 3, you just don't have utilities, and you have to reverse engineer the compiler. And that's the biggest difference between those two ecosystems that I can tell that we have. There are like other differences, but I think I'm over time already. So let's just leave it there and go to the summary. So when you like comparing Scala 2 and Scala 3 macros, some basic concepts are exactly the same on on either of them. Like we have types, we have expressions, we have type and untyped version of those things. We have symbols. We have to deal with abstract syntax trees. They are all the same. Some of things are placed in different things. Some the names are a little bit different, but everything's seemingly the same. However, when you get deeper and deeper, you can see that Scala 2 has a little bit more utilities. Like I haven't shown all of those useful utilities that you might be missing. That, like for instance, in Scala 2, you can check if a definition is public, so that you could call it. While on Scala 3, you basically have to check all the flags. If it's not private, if it's not protected, if it's not package private, package protected, all of that. So it's much more mundane, but at least you don't have bugs not fixed for 10 years. Still, both implementations have enough features to build upon them. So if you have any questions about maturity, then I would say, well, Scala 2 macros are mature enough that you can start building with them. However, you have to just assume that there is no documentation for any of them. Like there is some documentation, but it will not help you whatsoever. So if you want to learn about those things, then unfortunately you have to study existing projects, and this is where Scala 2 is better. Like it has much more projects that you can take a look at, learn the code, and try to steal some solutions from. If you want to some examples that you could steal from, then well, yes, examples and slides are available on my GitHub page. I also can recommend Chimney because it has a lot of things solved as much as I can tell, at least for now. But there are also other libraries which were ported to Scala 3, so they can also come in handy. So I think that's all for now. So are there any questions? Yes?
Code with defaults, when you try to decode the defaults, will it blow up when you have dependent values? Then they will be encoded in different way.
Just to repeat the questions, are the defaults encoded in a different way between Scala 2 and Scala 3? Or
if you have multiple parameter lists,
and on the second parameter list, the default value depends on something on the first parameter list, then this cannot be encoded, as I cannot imagine how it could be encoded as a method without the parameter lists. So if you're looking for just default something, then you probably will blow up somewhere there.
I would say that it should be possible. However, by default, I would expect it to blow up because you would have to explicitly handle it, check this, that the type that you are using was defined in the previous parameter, and so on and so on. So probably it would be quite a mundane, but you would be able to do this with,
But still, you cannot say which value it depends on. Even if it will be encoded as a function, which takes parameter, then you have no access to the knowledge which parameter was used from the first list.
Like when you are using defaults, I think the Scala only allows you to, basically define them in such a way that each default is a, parameterless method. Either, if you call it on a constructor, it's defined in the companion, but if you have a default defined in a normal function of some object, then this default will be defined in this object. So I think language itself will not let you define default in such a way that you wouldn't be able to call them. I'm not sure if that answers your question. Okay. Is there any other question? Okay, then thank you.